Hello everyone, this is Educant International. Today we are going to be looking at two questions for physics 151 practical. Okay, so the first question says reduce to linear graphs and write the slopes and y-intercept of A PV equal to K. Okay, so now for us to reduce to linear graphs, the first step we should take note of is that we have to find our variables and our constant. So it's already given to us. So from this equation, we know that our variable p is one of our variable, and then v is also one of our variable, and then k is a constant. So the equation can be complex more than this, okay, but you should know that to reduce it to a linear equation, there will be only two variables, the rest will be constant, okay, except in other conditions. So now if p equals to v equals to k, we know this is from Boy's law. Okay, so now reducing it, we get p v equals to k. So now converting it to a linear equation, I'm going to get p equal to k over v. So p equal to k over v is our linear equation. Okay, so now the next step is to compare this linear equation with the linear equation for a linear graph. Okay, so now the linear equation for a linear graph is y equals to mx plus c. This is linear equation for a linear graph. Okay, so now having this, then we know that p is equal to, so remember we said this is our constant, okay, times our variable 1 over v. Okay, so this plus 0, right? If you add 0 here, it's still this, isn't it? Okay, so now comparing these two equations, you are going to see that p will be equal to y, k will be equal to m, x will be equal to 1 over v, and then c will be equal to 0. Why is that so? Remember, this is a variable and the variable here is x. This is a variable and the variable here is y. Okay, so this is our slope, and then this is our intercept. So we're told we should write the slopes and y-intercept. So this is our intercept and this is our slope. So that's the answers. Okay, so the second question now, we have this, that we should plot a suitable graph to determine k and a standard error. So we can make a suitable, so I'm going to make my graph to be m against p. So you can make your graph p against m, or provided you can get your k. Okay, so now the this thing here will be for our y-axis. I hope you are seeing this. So for our y-axis, the unit is the like the scale is 2 centimeter to 1 unit, and then for the x-axis, the scale is 2 centimeter to 2 units. Okay, so now we are going to write down here, so that will be 2.00, 4.006. So you use pencil. Okay, so this will be 2.00, 4.6, 8, 10, 12, 14, 16, 18. Okay, so that is 1, 2, 3, 4, 5. So because of space, we'll make it 2 centimeter to 2 units. Okay, so remember, this is our p and then this is our m. Okay, so let me write down the one for M too. So the one for M, we are using 2 centimeter to 1 unit. Okay, so that will be after 2 centimeter, this another 2 centimeter, another 2 centimeter. So 2 centimeter to 1 unit. So this will be 1.00, 2.00, 3.00, 4.00, and so on. Okay, so this is our graph. You have 1.00, 2.00, 3.4.5, 6, 7, 8, 9, 10. Okay, let me expand it more. So now, to get the graph, we have our table here. So let's mark all the points on the p-axis first. So for the p-axis, the down one, so we have 4.1. Okay, so 4.1, so that's in between here, that's in between here and here. Then 7.8, this is 7, this is 7.8. Then 12.1, this is 12, 12.1. 16.1, this is 16, 16.1, and then 17.8, this is 17.8, 16.1 is in between, 12.1 is in between, 7.8 is here, 4.1 is in between. Okay, that's it. And then I will do 1.7. Okay, so this will be 1.7, 5, 6, 7, 1.7, 3.5, 5.5, 7.1, 8.2. Okay, so by the time you join them, that's my port. So by the time you join them, you get from here to here. Okay, then with this, this was, yeah. Okay, so this one is in between, so it's 5.5. The line between here. Then 7.1, 16.1, 16.1 is in between, 7.1 is here, and then 8.2, the last one. Okay, this is it. So now this is our graph. So join the line with our line of best fit. So let me make the points clearer. So this I'm saying that the camera is not that clear. Yeah. So now we take our line of best fit. So from yes to this. Okay. So you are going to use pencil for your diagram. I'm using Biro because of I want you to see what I'm doing. Okay. So now this is your graph. Okay, so from our graph, we're asked to find the value of k and determine the standard error. Okay, so let's find the value of k. Okay, so to find the value of k, you're going to take note that comparing k of equation m equal to p over k, or so this is plus 0, so this is still the same thing as m equal to p times 1 over k plus 0. Okay, so comparing this equation with our linear equation, plus c. Or yeah, p is a variable, m is a variable, y is a variable, x is a variable. So we have m to be a constant, so m will be equal to 1 over k. So this is our slope. Okay, and then c will go to 0. This is our intercept. So we will see that from here. You'll see that the line is tending towards the intercept. Okay, so now if we pick from here to here, we are going to get I'm just doing this as what you are going to do a graph. So you now pick this last one if you so wish. So you should know how to draw graph, or your friends can help you with that. Okay, so you trace this too. So your friends should be able to help you with that. So if you cannot draw graph, I think let me answer what I think is for me, our mind. Okay, so if you are going to check our graph with this, you are going to be saying that our 17.8 is joining with our 8.2, and our 1.7 is joining with our 4.1. Okay, so we just put them on our graph and then solve. Okay, so now from the graph m, now we don't have anything to do with our intercept, we are looking for k. So but we know that m is equal to this, our m2 minus our m1 all over our p2 minus our p1. Okay, so from our graph, this is going to be our p2 here, this is going to be our p1. Don't write that, you find a way of indicating it. I don't think you should write it on your graph. Don't mark them on your graph, except okay, so this is our m2 p1 p2 m1 p1. Okay, so it's the same thing to with our graph. If your graph is perfect like mine, okay, so that will be m2 is 8.2, so you can put 0 at the back, minus 1.70 divided by p2 is 17.80 minus 4.10. So this is equal to our slope m. So m is equal to 8.20 minus 1.70, that is 6.50. Then 17.8 minus 4.1, that's 13.70. So this will give us 8.5 divided by, so this is 0.47. okay, so you can leave it in 47, you can leave it as 4744. okay, so whichever way, so let's leave it there. So from here we see that m is equal to 1 over k. So that's from here now. So if we make k subject of formula, you get k to be equal to 1 over m. So this will be 1 over 0.4744. So this will give us 1 divided by 0.4744. So this is 2.1710079. So this is our value of k. Okay, so Now we have to find our standard error. Okay, so we'll go back to our equation. Okay, so for our standard error, Q2 Q2 is the height, that is, this our M2 is going to be our Q2, then our M1 is going to be our Q1, then this our P2 is going to be our R2, and then our P1 is going to be our R1. Don't write this on your graph work, just I'm writing them out. Then your N is your number of points, 1 2 3 4 5. Okay, so putting that there, we'll have Q2 now is M2, which is 4 times 8.2. Q1 is M1, N is 5, R2 is 17.8, R1 is 4.1. So by the time you solve all this, you are going to get is our standard error is 0.3796. Okay, so that's that.